PK52, the Saturday morning meeting, part two of talking about the engineering marvels of the all-new 2022 Tundra. Yes, I did make the Tundra shirt. I thought, if you're going to teach Tundra, you might as well spend the money and get you a Tundra shirt. So sporting a new Tundra shirt, got the I-Force Max right there. Woo! Everything is good. So let's talk for a second about engineering design. I've kind of come full circle now on this. I'm not going to call this a truck anymore. I'm going to call this a Land Cruiser with a bed on it. So everybody that's driven the vehicle, all the bloggers and the influencers and automotive news, they're excited about the truck. They've got a lot of positive things to say about the truck, but the on-road ride quality, they are going bananas on. They're saying this is a luxury truck, and we've yet to see the capstone, which is going to go even to the next level. So I call the big three of engineering, and I am not an engineer, but I do believe I could play an engineer on a series or maybe a movie. I think I could pull that off. But I'm not an engineer, but I call it the big three of engineering tech in a vehicle. Number one would be oxygen. Number two would be heat. And number three would be weight. And I like to break those down because when the engineers look at designing something, they're looking at, can I meet the government standards for fuel efficiency, emissions down the road? And also, how am I going to perform against the other manufacturers, and which direction do I need to go in order to make that performance? One of the biggest decisions that Toyota made was not to produce a choice of a V8 in 2022. A lot of people are going to have an issue with that. To me, it's an avenue. Right now, we're still diminished on how many new vehicles we can get. There's still a chip shortage. The Omicron COVID-19 is ramping up. It seems like everybody in America is getting it right now. So there's been a few hiccups, and now we have the inability to be able to get our product around the nation because we've got a shipping issue. So there's a lot of issues that are holding back new cars. It's not holding back pre-owned and certified cars. There will be people that will make the old statement, there's no replacement for displacement. I want a V8. I'll never own a V6. I went through that in the beginning of my career. I was selling four-cylinder Toyotas. And these people were coming over and going, well, I wouldn't get a four-cylinder. And why are you here? That's all we have. We don't have anything but four cylinders. And it was crazy how you had to fight the old big block V8 buyers that end up roaming into a Toyota store because they're never going to buy anything but a V8. It took years for me to move my dad into a V6 Toyota as we started producing some of the revolutionary V6s. And he still said, I wish it was a V8. He never understood that the power that we were producing out of our four cylinders at the time were more power and much more performance than any V8 he ever owned. There is still a lot of that out there, and there will be people that will fight that do not want a V6. So that puts the V8 certified Tundras in play. They're in play. I don't think they're ever going to be discounted because now there's a limited amount of these moderate to lower mileage V8s that will come back into the market. And so we've got a giant opportunity on the certified side for that certified Tundra. For dealers out there that aren't certifying right now because everything's selling so fast, you're taking a four-wheel drive truck with four-wheel drive components and you're putting a 7-year or 100,000-mile powertrain warranty, and if the vehicle's out of comprehensive, you're adding a 1-year or 12,000. These are both zero deductible warranties now on a vehicle that you're going to get MSRP for. So, a 2-year-old Tundra right now, as this launch comes out, we don't have any of the new ones. The low mileage V8s are really scarce. And so now you're making so much money on these certified vehicles. Certify these trucks. And I would even go far to make a suggestion that your certified program becomes so big that you now have certified cars that are built on a unibody, which would be cars and SUVs. And then the 4Runner, Tacoma, and the Tundra in that area of frame on. So we've got two completely different avenues to look at vehicles on the pre-owned lot. Diversification and opportunity for choice gives people a lot more reason to do business with your store. I can get this or I can get this. They're completely different. What's the difference and what am I looking for? And to be able to explain that as a sales professional is so very important. So let me get back to my big three: the oxygen, the heat, and the weight. So for years, it took me a while to understand that we no longer have a gas pedal. We have an air pedal. So the computer controls the drive and the powertrain of the vehicle. So when I accelerate, I'm not hitting a gas pedal anymore. I'm increasing the airflow. Then the computer exactly meters the gas and the air together, the oxygen together, to give me the best overall performance or best overall fuel economy. So this becomes a computerized system. So we have a variable valve timed engine with intelligence. So VVT, small I means it's an engine that can think. What does this engine think about? The number one thing this engine thinks about is how you're driving the vehicle. Let's go load first. Do I have a load of payload? Am I pulling a trailer or am I driving up a grade? Well, how in the world would a truck know I'm going up a grade? Well, the wheel speed gets slower while the throttle gets deeper. So I'm going harder to the accelerator pedal. And that math says, oh, wait a minute, you're climbing a grade. And so the engine can vary the valve timing to increase the amount of airflow into the engine. And that all you have to do is lease or buy a Tundra and it does that. Isn't that amazing? The next thing is if I hammer the throttle, wham, I go to the accelerator. Well, the computer knows that I want every bit of performance out of this vehicle that I possibly can get the moment I strike that accelerator pedal, and the engine lifts and I get more airflow. So that's VVTI. The last one is, I love this, on a four-wheel drive. When you go four-wheel drive low range, you're multiplying the torque. So you might be in first gear, four-wheel drive, low range, and be going through some mud, and way up high in your tachometer number, it'll be moving maybe 3 to 8 miles an hour. So once you break over a certain RPM, then the engine's going to lift, and it's going to perform as a bigger engine. Why is this so important? Why don't we make this work all the time so we'd have power all the time? Because the engine doesn't have to lift at all times, that means it uses less oxygen, less gas, and we can also provide better fuel efficiency. So best of both worlds, right? So the next thing we'll talk about is how oxygen gets into the engine. So if you look at oxygen as a molecule, the colder that molecule gets, the more oxygen you can get into space, a cylinder. So if you think about oxygen, if you super cool oxygen, remember I'm playing an engineer on TV, if you super cool oxygen, it becomes liquid oxygen, that's rocket fuel. So back in the old days of drag racing, so the last race of the day, why would you pack the intake manifold with dry ice? Well, by cooling that intake flow to the engine, you're increasing the density of oxygen in that cylinder, and the car's going to perform better. So what we've done is now we've twin turboed this vehicle. Well, the cool thing about turbocharger is it's going to force a more compressed air into that engine. And remember, all an engine is a giant air pump. The more air you can flow in, the more power you can produce. So why do I need a V8? I don't. If you make a V6 twin turbo that outproduces my V8, there's a lot of things going to change. Let's go to heat. Heat is a killer of everything. You put a car out in the sun, eventually the paint's going to deteriorate because the sun and the heat is going to deteriorate. So heat is a big problem. So we have a 13.9-inch front rotor. So big front rotors, 12,000 pound towing capacity. But I got to be honest with you, you want something not to stop? You go down the highway and you see these truck off ramps where if their brakes superheat, they can go into the gravel and not kill everybody on the highway. Okay, so once a brake rotor gets too hot, the brake doesn't work anymore. It's less efficient to the point or it won't stop. And so what we've done is we put graded vents in the front of the Tundra. They're very obvious, and those tunnel ram the airflow directly to the rotors. So now that when I am towing or I'm really working a vehicle off-road, I have a better chance to be able to cool that rotor down for more efficiency. So heat number one with brakes. Heat number two, intercoolers on the turbochargers. So as I cool that airflow down, not only am I forcing more air in, I'm forcing more oxygen dense air in there. That's a cooler airflow. In 2019, I think I'm calling this right. In 2019, we stopped putting a transmission cooler on the Tundra. I think that was 2019. You could double check me on that. So if I'm towing 12,000 pounds, gang, I want a transmission oil cooler. And so in the 2022 model of the Tundra, we have reenacted and we've added a transmission oil cooler. Again, keeping the transmission cooler so that 10-speed transmission can work more efficiently. And the last thing is weight. Okay, let's talk about weight. Weight is all about performance. So you and I both have the exact same vehicle. Let's say they're two Tundra SR5s, exact same weight, exact same equipment, and we both weigh exactly the same. So in that vehicle, these two vehicles are identical. Engine, performance, and everything. So it makes sense if we were racing that we would finish exactly at the same time. As long as our start time was perfect, as long as our acceleration and shift points were perfect, then we should end right together. So how am I going to beat you? I have no advantage. There's no advantage. These vehicles are exactly the same. So when you're not looking, I've thrown my spare tire out. When you're not looking, I took all the stuff in the back seat and I threw it out. I took everything. I took the front passenger seat and I threw it out. I took the carpet out of the vehicle. I took everything out of this vehicle that didn't need to be in there for this race, and there's no way you're going to beat me. So what does Toyota do? So what we do is we do aluminum hood, aluminum doors, we do aluminum composite bed in the back, and that's stripping weight. So why will this vehicle tow 12,000 pounds? Up to 12,000 pounds? Well, the first thing is the more weight you put in a vehicle, that's if you look at the actual towing capacity of the Limited and the 1794 and the Capstone, it's not 12,000 pounds because the truck weighs more. So more that you add to the truck, the less efficient towing and payload is going to be. But again, we're stripping that down. There's so many different things. If I do a V6, there's no replacement for displacement. Well, wait a minute. If I do a V6 versus a V8, now the front end of the truck is lighter. If the front end of the truck is lighter, can I clear more obstacles? Can I go more off-road? Does it become more efficient when I'm trying to drive the vehicle down the highway because I've reduced the overall weight? The answer is yes. And then the Dejima welding. So if you don't know the history of welding with Toyota, it's pretty amazing. So welding in the past, you take two pieces of metal that are exactly the same and you run a bead on those and you weld those two pieces together, and that's very efficient welding. Many years ago, Toyota designed a welding process that allowed us to weld two different thicknesses of the same metal. So I could have a metal like this and a metal like this, and I could weld them together, and the bonding of this laser welding actually melted the metal together, and that was revolutionary. To be able to do two thicknesses of metal. Now, gang, we can do two thicknesses of metal and two types of different metals. This Dejima process, which we paired up with a company in Switzerland to learn how to do that. So here's my frame, fully boxed frame. I want this to be very strong, and we'll talk about suspension next week, but I got my frame right now. I got my cross members that are bigger. I've widened the frame out in the back for more stability. I put my shocks outside the frame, which widens my stance, which makes all the sense in the world. I love riding down the highway and looking at a competitive domestic truck, and the shocks are right in the middle, hanging down together and hanging down below the axle, so off-road they can knock the rocks and stumps out of the way. So you're actually clearing a trail. You know what I'm saying? So I love the way they've set this up. But now, there are parts of that frame that I don't need to be super rigid. There are parts of that frame that's not an area where it's going to get a lot of stress. And so can I put a lighter weight metal in there? Can I lighten that part of the frame? And the answer to that is absolutely, with this new Dejima weld process. So what we've done is we've managed the O2 molecule. We are more oxygen efficient. We have dissipated heat. That means the truck's going to last longer and always perform better when you eliminate the killer of heat. And the last thing is, we looked at a vehicle, we built it as big and beefy and strong and more capable than ever before, and we've done it by reducing weight where weight was not necessary. I got to be honest with you. I made the shirt. I've been with Toyota for a very long time. This vehicle is revolutionary, and I'm going to clock you up. New F platform. So that means the Sequoia that you're going to see in just a few days, they're going to launch photos of it, is going to be built the same way. Can you imagine a Sequoia out of this Tundra? Come on, man. And then the next thing we have coming is the new 4Runner. It's going to be built on this it's going to be unbelievable. And I got to be honest, not everybody needs a full-size truck. As we revolutionize this next generation Tacoma, just get ready. You are working for the right company. It is incredible. The new 2022 Tundra is the beginning of the change of the engineering for Toyota. PK52, the Saturday morning meeting.